Hello and welcome to this lecture. In this lecture, we are going to talk about the most important things that you will be dealing with in this course. So we already saw a little bit of numbers. Of course, you will continue to deal with numbers, and we are going to use a lot of variables in this course. It's a lot of problems involve unknowns and quantities which we will denote using variables, and then we will manipulate them, and we will be defining functions using these variables, and all these variables and functions will be related through some relationships which are expressed as equations. So numbers, variables, functions and equations are part and parcel of mathematical technique. You learn this in school in various ways. I'm going to sort of show you how these arise in problems and how various types of mathematical techniques are needed to solve problems involving different types of variables, different types of functions, different types of equations. Okay, at least 2-3 types I'll point to. Maybe we won't see all the techniques in this lecture or in this week. Maybe some techniques we'll see. We'll start looking at some techniques on how to deal with these equations and functions and variables. Okay, so let's get started. So we're going to begin with examples of problem solving. Okay, so I'm going to take 3 problems and work them with you and show you how certain types of functions and equations and certain types of some forms will naturally arise, and you need techniques, or you need to really be sure about your techniques to solve problems involving such expressions. Okay, so that's the first step. I just want to motivate them from problems, right? So that you see that in very simple practical problems, these kind of forms arise, and we are not studying them for the sake of it, but they arise in practice in very practical problems in various types, and it's good for you to know how to deal with them mathematically. Okay, so that's the idea. Let's begin with a general approach. Okay, so this is a sort of a mathematical approach to problem solving. A lot of people sort of don't learn this as part of mathematics, or don't learn this as part of school. They learn a bunch of formulas, and they just learn how to apply them in various situations and forget about it. They don't approach problem solving in a mathematical way, and this is what is missing in some people. And when you don't understand this, every problem will look new and daunting to you. Okay, but when you understand that every problem that you approach mathematically has a very fixed way of proceeding, you will see that there is a very simple form to it, and you can easily appreciate how this is done. Okay, so let me just tell you how a problem is approached in a mathematical way. Okay, first thing is, the problem will have quantities which are expressed as numbers, right? So if you don't have any quantity which is expressed as number, typically math has no role in those problems, right? Those could be societal problems of different types, and usually there's no direct role of mathematics there. When you have numbers in your problem, many problems have numbers in them, it's just practical problems. So when you have that, then math will enter the picture. So you first have to identify the quantities which are numerical in your problem. Okay, and then you assign variables to these quantities, particularly if they are not known. Okay, if they are known, sometimes you assign variables, sometimes you just keep them as numbers that you know. But quite often, some quantities will be known to you, some quantities may not be known to you. And anything that is not known or you have to figure out, you use a variable. X, Y are common variables. You can also use A, B, U, V. If you know Greek alphabets, you can use alpha, beta, make it look more sophisticated than it should be. So you can use anything like that as variables to denote these quantities. Okay, so this is the first step. So look at a problem, identify numerical quantities. If you know them, well and good. If you don't know some quantities which are very important for solving your problem, you assign some variables to them. Next comes the first step, which is basically to identify simple basic relationships between these quantities and variables. So now these quantities arise in the physical world. Okay, so there are physical laws governing them, there are rules governing them. If some of the quantities could be cost per item, and then your variable might be number of items. Then what's the total cost? That's one simple relationship, right? Cost per item multiplied by number of items you bought, right? So that gives you a very basic relationship, right? So you go ahead and identify that. Sometimes the basic relationship will involve some assumptions or definitions, right? You'll say, okay, I don't know, but I'm going to assume that this is a relationship that is satisfied. So sometimes such things happen, but usually these are justified by physical laws and rules, maybe some geometry of the problem, maybe some basic structure of the problem. You use that, and simple relationships that's the starting point. Then comes the actual sort of math behind the problem. So up to 1, 2, 3, one can argue it's mostly very basic, if at all, very basic mathematics. You're not using anything sophisticated. Now, after you've identified basic relationships, when you want to try and compute the unknowns, solve for the unknowns, or do some computation with all these quantities, you may have to use sound logic, good logic and techniques from mathematics. So that's where your comfort with mathematics will come in. You look at these relationships and identify, oh, you know what, this falls under solving linear equations, this falls under solving quadratic equations, this falls under using logarithms, this falls under using trigonometric functions, whatever. So all these things will enter the picture at that point, and your knowledge of those branches of mathematics and mathematical techniques will help you make progress and solve the problem. Okay, so this is the general flow for any problem, in my opinion, right? Any problem you see in life, you can use a flow like this. But of course, the numerical problems are very direct to solve. Other problems are a little bit more complex to solve. Okay, so I'm going to use this approach and show you 3 problems, and we'll use the same approach and try and identify numerical quantities, assign variables, try and find basic relationships, try and find slightly more involved relationships to solve the problem. Okay, we'll start with very simple problems. All 3 of them, in fact, are very simple, very high school level type problems. You should have enough experience with it, so that the area itself is not too complex. I can focus on the mathematical technique involved. Okay, let's begin with the first one. Okay, so it's shopping, the kind of problems you see in 4th standard, 5th standard, 6th standard type thing. Very simple shopping problem, and this ends up having some sort of a linear relationship. Linear equations will result in this problem. So let's just go through the problem real quick. There is a shopper. I haven't named the shopper. This is the shopper. Usually the word problems will give you a name for the shopper. You can imagine your favorite name. If you want, maybe we can say Shah Rukh Khan, who knows, right? So the shopper needs to buy a total of 5 kilograms of apples and oranges with a budget of rupees 1000. So there's 1000 rupees for the shopper. A total of 5 kgs have to be bought. Why 5 kgs? And maybe the bag the person carries can carry only 5 kgs. It'll break after that, who knows, right? So some rule like that. And 1000 rupees, why 1000? I mean, that's all, right? So the person has only 1000 rupees. So that's it. So there is a cost per kilogram for the apple, which is 250. Slightly expensive apple, maybe imported variety, who knows. And then oranges cost rupees 125 per kg, slightly cheaper than apples. You get a lot of oranges here in India as well. So this is the situation here, and the question is, how many kgs of apples and how many kgs of oranges can the shopper purchase? Okay, so there are a lot of quantities here. There are apples, oranges. Total is 5 kg. Total amount of money the person has is 1000, and there's also 250 per kg for the apple, 125 per kg for orange. Okay, there are 2 unknowns here, and the 2 unknowns are actually being pointed out in the problem itself. But you can see the weight of apples you can buy is one unknown. The other unknown is the weight of oranges you can buy. Okay, so you first, so when you solve these problems at a very young age, you first write down everything. All that I know, all that I don't know. What you don't know, you put a variable to. Now we are already at college, so we can quickly identify what the variables are. Okay, now comes the next step. So what have we done? We've identified the numerical quantities, we identified the variables. So there are 2 variables here. So maybe I should see if I can write that variable down. So x could be one variable, which is weight of apples that are purchased, and y could be one variable which is weight of oranges purchased. Remember, there are a lot of numbers. I know 250 is the cost per kilogram of, so this is in kilograms, right? Kilograms. Okay. So there are conditions that are given as part of the problem. What are the conditions? There are two conditions. A total of 5 kgs have to be purchased and the total budget has to be 1000 rupees. So each of these will actually define a condition or a relationship or an equation for you. Okay. So the total weight is what? If you bought x kilograms of apples and y kilograms of oranges, the total weight clearly is x plus y, isn't it? Just add. Okay, so this rule is easy enough. Now, what should the total weight be as per the problem? The total weight has to be 5 kgs. Okay, so this equals 5. Okay, so easy, isn't it? It's a very easy basic relationship. And then the total cost is 250 times x plus 125 times y, and that's going to be equal to 1000, right? So 1000 is the budget here. So maybe I should just show you 5 kilograms and rupees 1000 and 250 per kg for apples and 125 per kg for oranges. So some people like to underline. You can underline that as well. So that's where we are. Okay, so we've used all of those things, and now we have these wonderful looking equations. So let me just write down those equations once again. X plus y is 5 and 250x plus 125y equals 1000. So in fact, this equation we can divide by 125, right? So some comfort if you have. So this equation is the same as what equation? 2x plus y equals 8, isn't it? So you see, quickly you identify, you can divide throughout by 125, right? Everywhere, every term, and you get this. Okay, hopefully you've seen these things before. So notice here, you're already requiring skills to manipulate equations. Okay, so what are the various skills and techniques you need? The techniques is manipulate equations. Some manipulations are very simple, like you just divide throughout or multiply throughout. All these things you might have seen before, and I will expect that you have some comfort with it, right? So you know why you can divide by 125 throughout. This is an equation, and you get this. Okay, so instead of writing this complicated looking equation with a lot of terms, I see I have 2x plus y equals 8. So this is where I am. Okay, now I have to solve for x and y. So this requires some math technique, right? Okay, so we saw that there were two basic math techniques here. The first one is forming these equations, manipulating them here, there, etc. There is some basic algebra type math technique there. Once you get the final form for these equations, you have to try and solve for the unknowns, and that also requires another type of math technique. So these kind of equations are called linear equations in x and y. We'll study a little bit of them later on, y linear and all that we'll see later on. But these are called linear equations in x and y. So you have two linear equations in x and y, and you have to try and solve them. Okay, so these equations came in a very, very nice and simple way from a very small problem. It's a very toy problem. You might think it's not engineering in difficult electronics system design. You may not get equations like this. I can tell you these equations show up all the time in circuits, and even if you're putting together a big system, right? So for instance, your system might have a budget, right? The board you're making, the system you're building will have a budget. So all the components that you have to buy, the cost per component multiplied by number of components is the total cost, and that needs to be within a certain budget, right? And there may be other limitations. For instance, the weight of the components may have a constraint. So whether you like it or not, linear constraints, linear equations will enter your design. And if you're a master of looking at problems, writing down equations, you will do all this naturally. And when you do all this naturally, your problem solving becomes much better. Okay, so linear equations show up in pretty much every problem you can imagine. Okay, so they're very basic and fundamental. Being able to solve them will go a long way. Okay, so at this point, I'm not going to solve this equation at this point immediately. This is just to illustrate the approach of how to approach a problem. We come up to an equation and we'll stop here. Later on in this week's lecture, we will see how to exactly solve this problem in multiple approaches. And then later next week, you'll learn a more general technique of how to solve linear equations. But for now, at least I've motivated for you where linear equations come from in a very simple problem like this. And hopefully you're convinced that you'll see these in other problems as well. Okay, so that was the first problem, and we have made some significant progress in this problem. We haven't fully solved it. Maybe some of you have already solved it. It's an easy enough problem in some sense. But right now we have at least come up to equations which maybe hopefully we can use and solve going forward. Okay, so that's the first problem. Let's move on to the second problem. Okay, this is about farming. Okay, the previous one was shopping, this one is farming, and guess what? You'll end up getting some sort of a quadratic equation here. Okay, it's a very similar problem to previous one. I will let you read it for a while, and I'll also read it with you. There's a farmer. He's planning to grow a crop, and this is very typical. You have to go borrow some money so that you can buy seeds, buy fertilizer, whatever, and then grow a crop in a square shaped field. Okay, we are making it easy, just saying it's square shaped, and there's an electric fence around it. I mean, depending on the area where you're doing the farming, if it's close to wildlife and other animals and you want to protect this crop, maybe it's a sugarcane crop and elephants like to eat it, so you need an electric fence around your field, and there is a cost for maintaining the fence, building it and maintaining it. It's about 100 rupees per feet of the perimeter of the field. Okay, so I don't know if that's a reasonable cost or not. I just pulled that number out. I just left it there. So your fencing is going to cost you 100 per feet of the perimeter of the field. Okay, and the earning you will get ultimately when you grow the crop, and the crop, assuming the crop has come out well without any natural calamity or anything, and then you have the harvest, and then finally your profit is about 50 rupees per square feet. Okay, it costs a lot to grow crops. You have to pay for labor, you have to pay for fertilizer, seed, and water, and electricity, this, that. And then after the crop has grown, you take it to market and sell it, and the cost, the selling price minus all your cost is about 50 rupees per square feet. Okay, so that's changes from crop to crop. For this particular crop, that's the number that you have. Okay. So now the farmer is interested in a final profit of rupees 10,000. So final profit after all the costs and after repayment of the borrowed money that he's got. Okay. Now how big should the field size be? Okay, so that's the question. I hope the question is clear. So the farmer is trying to figure out how big he should make his field so that he can eventually get a 10,000 rupee profit. Is that okay? I hope it's okay. Maybe we'll get a very ordinary answer to this question. I don't know, maybe the answer will be reasonable. Maybe it's a very fancy cash crop, right? So maybe a small area itself will give you a lot of profit, etc. All those things you can say qualitatively, right? Now I've put for you a quantitative problem. Okay, there's money involved, and you have to give me exact answers. You have to proceed logically, precisely, and give you an answer. That's the mathematical approach, right? That's our approach. So let's see if we can do that. Once again, maybe I can underline the important things. There's been 50,000 rupees borrowed, and there is rupees 100 per feet of the perimeter and rupees 50 per square feet of the area, right? So there is 50,000 is a cost for you. You have to pay. 100 per square feet is again you have to pay. Rupees 50 is profit, money that you ultimately make, and your goal is to have an overall profit of rupees 10,000. Okay, so sometimes, not sometimes, I would say all the time, pictures help, right? So you have a picture. So let's say this is the field, no? So we'll draw it in green. So here's your square field. And what I need to know, what is the unknown? The unknown is this x, which is the side, the length of the side of the field. I don't know how big my field should be. Once I have x, what is the total perimeter? The perimeter is 4x, right? So you have x, you have x here, you have x here, and x here, and the total perimeter on which fencing has to be done is 4x, isn't it? So it's quite easy to calculate. So perimeter is 4x. Okay, maybe I don't need green anymore. Perimeter is 4x. Okay, and then what's area? Area of a square is x squared. Okay, so all these things are basic relationships, right? Perimeter is 4x, area is x squared, 50,000 rupees the person has borrowed, he wants a 10,000 rupee profit. So I need final profit expression. Final profit is all that you have earned minus all that you have spent, right? So what is your earning? You get 50 rupees per square feet at the end, after a long time. So I'm not accounting for things like interest you have to pay and all that. Of course, in practice, all that you have to add. So maybe the 50,000 is with interest and all. Okay, so 50x squared. And believe me, interest from loan sharks is a huge problem for farmers in this country. So you have 50x squared, and then this is the money you make, right? The total money you make, and you've spent 100 times 4x, right? This is your earnings from the selling. This is your fencing cost, right? 4x is the perimeter times 100, right? That's 100 rupees per feet of the perimeter of the fencing, and minus the 50,000. This is your borrowing. Okay, like I said, things like interest and time for the crop and all that is very, very important, but we have not taken care of that. So this is the final profit. And notice what I want. I want the final profit 50x squared minus 400x. Notice this manipulation I'm doing. 100 into 4x is the same as 400x minus 50,000 equals, we want to solve this guy, right, equals 10,000. Okay. Wow. So we have taken a mathematical approach to this problem, and we've ended up in a equation. And notice the difference between this equation and the previous equation we had. The previous equation had two variables, x and y. This equation has only one variable x, but there was no x squared in the previous equation, right? It was only x and y. So that's what makes it linear. Once you have an x squared term, it turns out the fundamental nature of the problem changes. The techniques you need to solve these problems are very, very different from the techniques you need to solve linear problems. Okay, so this kind of an equation is called a quadratic equation. So of course, in your school, you have seen how to solve quadratic equations. You know all this, but I thought I should give you a little bit of a glimpse on how a very practical problem can result in a quadratic equation. And this is not the only problem that results in a quadratic equation. Even in electronic systems and electrical systems, quite often powers of a unknown parameter come in. Area enters the picture in an electronic system design if you're doing, and area is related to the length of the side, and if you're determining something like that, it enters the picture. Length of wires matter, the cost matters there sometimes. There are also even deeper results, like some devices in electronics like MOSFETs, if you know them, they follow a quadratic law. There's lots of reasons why quadratic equations show up. The x squared term shows up in a engineering or a science problem, and this is a simple area problem. And area is one such thing where the squaring happens, right? So the area of a square is x squared, no? So that is like the fundamental way in which quadratics show up. Okay. Once again, we're not going to immediately see how to solve this quadratic equation. Later on, I will show you a graphical and a analytical way to do it very quickly, and then we'll come back at that time and solve this problem. So at least I've given you one more example in this problem of how if you take a mathematical approach, you're going to get an equation, and that equation can have a different form, and in this case you get a quadratic. And it's actually not too hard to cook up situations where you get cubic terms, x power 4 or something else like that. There are various problems. You may involve, there may be a volume involved, and if you have volumes, you know that power 3 can show up, and then sometimes power 4 will show up. There are more interesting problems where all these things can come up. So the actual equation you get may be even a polynomial, right? A higher degree polynomial than just the quadratic. But this is a math 1 course, so we'll stop with quadratic as of now. Okay. So how to solve a quadratic? You all know it, but still we'll quickly see it later on. So this naturally arises in various problems. Okay, so that's problem number 2. Hopefully this is interesting, and you see how these things show up. Okay. So the third problem we're going to see is about banking, okay, making money, right? And here a very interesting form called the exponential form will show up. Okay. So let me just read through the problem for you. You have 1 lakh rupees with you, and you want to invest it. There are 2 options, and you want to compare. Okay. You want some returns at the end of a year. 1 year investment you're ready to do. One option is to go for a 10% simple interest per annum. Okay, so I'll tell you what this relationship means. So this will tell you, this will give you a certain return. Okay, and then the next one is a compound interest. Okay, 1% interest compounded quarterly. Okay, what is quarter? Quarter is 3 months. There are 4 quarters in a year. 3 months. Every 3 months, you get 1% interest on whatever you deposited, and then that money is added into your deposit and then invested again. Again, you get a 1% like that. Okay, so that's compound interest. So many banks offer simple interest. Many banks offer compound interest of different interest rate, and you have to compare the returns between these two and make a choice. And there's another very intriguing question. It says, what rate of quarterly compound interest? Right now, this is 1%. What rate of quarterly compound interest is better than 8% simple interest, or maybe 10% simple interest? Why 8, right? So we'll make this 10. So this problem is 10. Okay, so all right. So this involves some interest rate and all that. So let's just look at some basic relationships and how to go about doing it. Okay. So you have a deposit amount. Which I will call D. This is in rupees, right? So some deposit amount D. So if you have a simple interest rate of 10% per annum, okay. So returns interest earned in 1 year is just what, 10%, 10 by 100 times D, which is D by 10. Okay. So D was 100,000. The reason why I write D here is now 100,000 is a very long number. I don't want to keep on writing 100,000, 100,000. I write D, and finally when I get the answer, I'll plug in the 100,000. So I get 10,000 rupees simple interest in 1 year. Okay. So this is the simple interest calculation. So now compound interest is a little bit more. This is 1% per quarter. Okay. So how does that work? So 1% per quarter. So you get 1% return in 1 quarter. So the interest earned in 1 quarter so normally, you will see that banks always say this 4%, and then they'll say prorated to 1 quarter or something like that. I'm just giving you the 1% itself directly. So interest earned in 1 quarter is 1 by 100 times D, and that will be D by 100. Okay. But I don't take this money out immediately, right? I'm going to take it only at the end of the year. So what do? I compound, okay? So now deposit for next quarter. So let me just say quarter 1. Okay, this is better, 1 quarter instead of that. What is the deposit for quarter 2? Okay, initially the deposit was D. At the end of 1 quarter, you got D by 100. What's going to be the deposit for quarter 2? You invest the D by 100 back into your deposit, right? So it's going to be D plus D by 100. Okay. Another way in which people write this is to take the D common out and you'll get 1 plus 1 by 100. So it becomes 1.01 D. Do you agree? Okay. Simple calculation. So this has been deposited now. Now what is interest earned in quarter 2? I'll write Q2 instead of quarter 2. It's going to be 1 by 100 times. So rate remains the same, times instead of D I have to put 1.01 D. Okay. So then you have deposit for Q3 is what? 1.01 D plus 1.01 D by 100. Okay. Notice interestingly this becomes, I can take 1.01 D common outside and I will get 1.01 whole squared times D. Okay. Now interest earned in Q3, I am just writing it a little laboriously and you will see there is some sort of an iterative repeating formula that will emerge, and that is very central. Anytime you have something that repeats iteratively over and over again, you will start having some sort of an exponential behavior. Okay, so you see the square has come and you will see interest earned in quarter 3, it will be 1 by 100 times 1.01 square times D, right? And then let me write it, let's go up here, oops, there you go. So you have deposit for Q4, I mean eventually you can write it a little bit better than this, but I'm just writing it a bit more laboriously. D by 100. So you see, notice here 1.01 power 3 times D. Okay. So now at the end of 1 year, you're going to take it out. So again, so let's say interest earned in Q4, it's going to be 1 by 100 times 1.01. I'm just laboriously writing. I hope some of you are getting quickly final maturity amount at after 1 year, right, is 1.01 power 3D plus 1.01 power 3D. This exponentiation will end up happening. So you will get 1.01 power 4D. Okay. So one can do a quick calculation. Okay, so to do power 4, you just have to square it repeatedly. So you see you get 1.04. So this is 1.0406. Okay, so we'll stop there, right? 06D. Okay, so approximately, let me just say, there is some approximation there, but it's okay. Or maybe you can write it out entirely if you want. Okay, so the earnings you got here is roughly like so previously you got 10,000. Here you're going to get what? So this is equal to, you multiply by 1 lakh, I'm going to get 104060. Okay, so that is the final maturity amount. So the total earnings is so interest earned in 1 year was 10,000. Interest earned in 1 year is 4,060. Okay, So you see, with 1% interest rate compounded quarterly, you're getting 4,000 rupees, okay, 4,060, a little bit more than 4,000, and that is lesser than the 10,000. So you would go with a 10% simple interest. Okay, so hopefully you saw the calculation here, and hopefully you see how this 1.01 is being where did it come from, and how the powers of 1.01 are coming up. So this is where the exponentiation is happening. When you iteratively, repeatedly do some additions and multiplications, you will end up getting exponentiation. Okay, so repeated multiplication is exponentiation, right? So that's what's happening here, and this also is a phenomenon that's very common, not just in banking. It happens in electronics as well. It happens in various other situations like population increase and so many other places. In fact, even website traffic, a lot of things, this kind of multiplicative effect happens. So some people come, and because of that more people come, and because of that more people come, and all that. So there is a multiplicative effect. Anytime you have a multiplicative effect like that, then you have an exponential behavior. Okay. So just like we saw that there is very easy ways in which linear relationships come. There are very easy ways in which quadratic relationships come. There are very easy ways in which exponential relationships come. Okay, and hopefully you saw that here. I didn't write down a very general formula, but you might have seen this before. So if you have the compound interest is R% per quarter, the interest earned. So we see that so in general, when you want to write the formula, the compound interest is R% per quarter. The total amount earned in 1 year is going to be D times 1 plus R by 100 raised to the power 4. The total amount earned in X quarters is going to be D times 1 plus R by 100 raised to the power X. Okay, so that's important. So the interest earned in 1 year is D times 1 plus R by 100 raised to the power 4 minus D, right? Okay, so let me be careful here. Minus D. Another way to write it is D times 1 plus R by 100 raised to the power 4 minus 1. Okay, I take D common out, I get the minus 1. So this is the interest earned in 1 year. You can also write down interest earned in X quarters. It will be D times 1 plus R by 100 raised to the power X minus D. Okay. So what happened in interest earned in 1 year for simple interest? Simple interest was very easy. The interest earned was just D by 10. So you can equate these two guys, right? So for the second part of the problem, if you want 8% interest to be the same, how do I get 8% simple interest? So let me just do that also here. So if I have simple interest RS, let's say, percent per annum. This is very easy, right? Interest earned in 1 year is D times RS by 100, isn't it? So it's very easy to see that. So if I want to equate these two, I'm going to equate D times 1 plus R by 100 raised to the power 4 minus 1 to be equal to D times RS by 100. So in this particular question, we know that RS is given as 8 and what is R is the question, right? So see here, D and D will actually cancel in this equation, and you will get this slightly very interesting looking equation. So you should cancel D and D, you will get this interesting little equation where it says 1 plus R by 100 raised to the power 4 equals 1 plus 8 by 100, right? This 1 can come to this side, and 8 by 100 is here, so I've cancelled the D, right? So you get 1.08. So this is the equation that you have to solve to find what compound interest rate compounded quarterly for 1 year will give you the same interest as simple interest, which is at 8% per annum. In these three problems, I motivated the way in which numbers, variables, functions and equations show up in any problem that you want to solve precisely, logically using mathematics. Okay, so you're going to get that, and you need to start building up your skill in being able to solve these kind of problems. All these are easy problems. You have seen this in school and all that, but hopefully I've just given you a quick motivation for where all this comes from. And even in electronics, such things happen. So inside semiconductor devices, particularly diodes, BJT transistors, exponential behavior happens. So you put a small voltage at the input, the current flows, the current that flows is related exponentially to that voltage. There's some buildup that happens iteratively inside with electrons and holes and things like that. Okay, so exponential behavior is common in engineering systems. Quadratic, of course, is common. Linear is very, very, very common. At least in the models, we will use all of these kind of functions in electronic systems, and definitely in life, in various aspects of life. When you want to do problem solving mathematically, you will face all these type of functions. Okay. Just to summarize, problem solving involves defining quantities, defining unknowns as variables and identifying basic relationships, and then working with expressions. You have to use these variables and constants and derive newer and newer expressions. You should know how to cancel some terms, you should know how to add terms, subtract terms and all that. And then finally you will end up with some equations which define the problem for you, and you have to be able to solve this problem. Okay. So I've given you some basic examples here. You're all familiar with this Ohm's law, so that defines the basic relationship between voltage and current if you're solving a problem involving circuits. If you're doing a problem of movement of objects and motion of objects, then you have formulae like distance equals speed into time, you have Newton's laws and things like that. These physical laws give you very simple relationships, and you may have to use them to derive more and more complex equations. I showed you 3 simple examples, and there can be more interesting examples that have very interesting equations as well. So in general, the mathematical approach to problem solving involves finding and solving equations. Okay, so these are not idle things to just mug up. These are very useful. Quite often when you're faced with a problem, the tricky thing is to how to find these equations. Okay, very often you may know how to solve them, or there may be a computer which can somehow do something and solve it, but finding these equations is very tricky, can be tricky. So many people will take a very non-mathematical approach. They're a bit afraid of these equations, so they'll take a non-mathematical approach, and I can tell you a mathematically oriented person can solve problems much more efficiently if they are not afraid of coming up with these equations and trying to solve them. Okay. Couple of quick things I just want to point out before we close this lecture. We saw that we did a lot of algebra, and as we go forward in this course, we may do more algebra. Okay. So this is basically manipulating expressions involving numbers, variables using addition, subtraction, multiplication, division. I'll show you 3 examples here. I'm not going to go into great detail on how these things were derived and all that. You can check for yourself how the multiplication works, how do you add fractions, how do you take the common denominator and all that. So these are things that I will assume you have some familiarity with. If you've forgotten these, go and check and why these things have to be true. The last one is a little bit of a challenge. You may want to try and prove that for any n, may be a little bit of proving that's needed there for you. Okay, but you can do this. So these kind of things I'll assume you know. Okay, I'm not going to spend too much time on this. When I have to derive it, I will go slow. I will show you how this happens, but I'll expect some comfort in these kind of manipulations from your side. Okay. So that's about that. I think we'll stop with this in this lecture and move on to the next one. I hope this lecture was clear. It's sort of critical. It didn't have any too many difficult ideas or techniques, but nevertheless, the basic nature of mathematical problem solving is what I wanted to focus on. I hope you got that fundamental idea of how these equations come in an actual problem and why it is important to solve. Okay, thank you very much.